Howdy, everyone, and welcome. I am Kevin Blanco, Senior Developer Advocate here at Appsmith. And hey, the live sign is on right now, which means that we are ready to kick things off. And I couldn't be more excited because today we have an amazing featured guest who is ready to bring valuable knowledge for all of us. As usual, I love to see the global impact and reach of our community, so please let us know in the chat where are you joining from. I'm located in the sunny in the morning, super rainy in the afternoon, Costa Rica right now. But hey, shout out in the chat where you're tuning in. I usually love to see those messages. In case you missed it, we just had our launch week. It was massive. We announced a set of new features and benefits for you, like the long-awaited UI packages, Git for packages, 15 brand new integrations, major performance improvements across the board, and our brand new business cloud, which is live. So go and check that out. Look, there is no secret. We'll work at companies, and there is a true reality. They all have data silos. That's the reality. Most of them are disconnected between legacy systems, a bunch of databases or SaaS products, or even worse, spreadsheets. We all have been there in companies that uses spreadsheets, and this makes nearly impossible to search intelligently. There's no way to make intelligent searches over there. Now, a great mechanism to solve this is RAG. We have been talking about RAG, right, for quite some time, and it's a great way to augment the search results. But there are, these are still basic vector searches that sometimes do not have context about the relationship between these data points. And at the end, the data true value lies in the relationships. So let me just give you a brief example to get things started. Let's say that you get a customer support question which says, which supplier should we contact about our delayed laptop order? Now, a standard RAG response could augment that question to get, for example, data from a knowledge base about suppliers, and also could get data about your orders from the e-commerce API, whatever e-commerce system you're using. And it can respond something like, our laptop supplier is managed by a third-party provider. In this particular case, when we have third-party involved, we recommend you contact them using the third-party@company.com email. Now that's a fairly good response. It's not a lie. It's actually getting data from multiple sources, and it's providing a useful response. It's not hallucinating. So that's fine. I'm not saying that's wrong. But let's think for a second for a graph relationship question and answer that can actually provide a better context. So in this same question that we got, we could obtain customer order from a commerce API. That will tell us the product, which is a laptop. Then that can tell us which brand the product is, which is Dell. Now it turns out that the Dell laptop supplier is Tech Corp, and Tech Corp, which is the name of the supplier, uses a delivery service called Fast Ship. And it turns out that we know that Fast Ship staff member is called Sarah Chen. Now we get all of these different data from different services, but we're capable of understanding its relationships. That's where the magic happens. So watch this better answer. You need to contact Tech Corp directly, speak with Sarah Chen, who manages Fast Ship, and they have actually had already 3 delayed laptops shipments this month, affecting other 12 customers. That's a whole different world, right? That's a whole different world. So hey, why do I keep talking about this when we have both masters, Joseph and our special guest today, to elaborate more on this? So, Joseph, take it away.
Hey, thanks, Kevin. Yeah, we got an awesome demo planned for today. So we're going to be comparing vector RAG with graph RAG, or retrieval augmented generation. Now, if you know anything about RAG, it's very common to use a vector database. Pretty much every AI system that performs retrieval, it's probably using a vector database, but graph RAG, or graph databases for retrieval, are becoming a lot more common, and they have some really good strengths over vector databases. There's places where vector is still better, but there's some certain features with a graph database that can answer questions in ways that a vector database could just never answer. And so we have a special guest today to tell us more about it. So I'm going to bring in Jason from Neo4j.
Hi, everyone. Thanks, Joseph. Nice to be here. Thank you for running this.
Yeah, thanks for joining us.
Cool. I guess a quick intro. My name is Jason Koo with Neo4j, developer advocate here for a number of years. And Neo4j, if you haven't heard of us, we are a graph database company. And basically, if you have data where relationships between entities is really important, you should consider using a graph database. Use cases that would probably come to mind is basically any social network, including services like TikTok and also like Google Maps, right, for finding fastest path between two different places. Under the hood, those are all graph systems, including, Google's famous page ranking algorithm is a graph algorithm. So when you put data in a graph, you also have access to all these powerful algorithms that weren't available in the past. But here we're talking about, the future AI and graph rag systems and how all that can connect and give you more power on top of the existing data that you have.
Awesome. Well, I'm excited to see it. I've got a demo set up where we're connected to two different backends for RAG. So we'll be connecting to Pinecone for the vector retrieval. And then for the graph side, we've got a backend that you set up for us with Neo4j. So before we get into the details and the technical side, I thought it would be fun to just demo it first, to ask it a couple questions, see which one does better, and then we can talk about why and really look under the hood and see how this stuff works.
Yeah, let's do it.
All right. So we've got an app that we built here that is going to show us a response side by side from Pinecone and from Neo4j. And so before we get to the questions, I'm going to show you just a part of the data set here. I don't have everything pulled up, but this is a synthetic data set that Jason created for us. And there are a lot of related records where you only have an ID, like works for here. You've got an ID for this staff and who they work for. Here, it's kind of a reference back to the same table. So the data is there if you want to know who, the employee here works for number 5. And so it's Dennis right here. But then there's tables where, let's see, I think the order one. Yeah, this one's all IDs. It's just numbers. And so to answer a question on this is kind of complex. Like you'd have to figure out if you wanted to know which product sold the most. Well, you could figure out what number it is, but then to know the name, that's in another file. And if you want to know who bought the most of that one, that's in another file. And so it gets tricky to answer questions that link all of these together. But we're going to try it. We've got the exact same data set in a vector database in Pinecone, and then also in Neo4j. So that's the type of data that we're working with. And then we have some questions here. So I'm going to start with this one. And we're looking for the staff member that manages the delivery service that handled the largest number of orders by combining all the products sold. So there's a lot to this. It would have to figure out, the company and like the total number of products and then which delivery service. So we're going to try this out. And I have this set to run an API to both. It's sending the exact same prompt to Pinecone and Neo4j. They both have the same data available, but the way that they're querying it and the way that they access it's going to be totally different. They approach the problems differently. You can see that Pinecone here using the OpenAI, I think we're using GPT-4 here, and it's gone through and given us all the steps and everything and tried to answer it logically, showing its work basically. And it's come up with staff ID number 4. And then if we look on this side, it's just giving us the answer without all of that explanation. And it's not giving us the ID of the person. It gave us their name. So if we go look here at number 4, and there it is, Tomoko. So it was able to answer on both here. Like I said, the approach is totally different. The files that were retrieved and the way that it's approaching it may be different, but they both got this one correct. So there are certain ones that they're both going to be good at, easy questions. Then there's ones that only a graph database could do, or only a vector. So, Jason, what type of questions do you think are best suited for graph?
For graphs, anything that's what you would think of as kind of like a multi-hop question, right? Something that requires like traversing relationships. So, or like a nested type question, like what is the combination of the customers who buy the best-selling products, not like a single product, but maybe in combination, either by number, by region, by some other sort of number, and maybe even go even further, right? Like who is the staff member that's a point of a contact for this company, right? So the more hops you go through for a type of question, those make really good graph questions.
Awesome. Now, I think we have a couple more examples of questions here. And I believe you had one or two that had that kind of multi-hop. So here we're looking at the top selling products by combining all orders and looking at the MSRP column. So there's a couple different prices in there just to specify which one we're using for the total. So let's see what we get on this one. Now, I've noticed the Pinecone one usually responds first. It is a single service that's doing everything for us. It's performing that retrieval and then hosting the model, prompting it, giving us everything back in one shot. I know on your side, you have a similar system of retrieval and then sending that to a model, but you've wired all that together yourself with multiple services. So that's expected that it's slightly slower there, but yours is actually digging a little deeper, I think, to perform multiple queries and then combine those results. Do you want to tell us a little bit about that? Maybe this would be a good place to pull up those slides. So yeah. So first, we're going to look at a basic RAG pipeline. A couple of years ago, this would be how you would build it. Today, there's some easier options. I'm using Pinecone. But before we get to that, I want to talk about what it's doing for us in the background, because it's really removed a lot of the complexity for us. So normally the user would submit a prompt, and if you want to perform RAG, retrieval, that's going to go to this retriever that sends data to sends your prompt to the vector store, and it has to embed the prompt so that it can compare it to those other embeddings. It'll find any records that are similar, and then that gets sent with the original prompt to the final LLM. So, this stuff involves AI, but it's not the generation model that's answering the question. That's here at the end. And so here you're turning your prompt into a vector, see what comes back, combine that, then you can send it to the LLM, and then finally you get a response back. And to connect all of this stuff, you would generally have a post request to send the prompt not to the LLM, but to the vector store first. So before you can even get to prompting, you would send that prompt to the vector store, and that's one API. And then you get back some data, and then you're going to send a second post request to the LLM with the extra data that you got back. And with OpenAI assistance and pretty much with every LLM and AI tool when they first came out, this stuff was kind of slow, and it just gave you back an ID. It would not respond immediately. So you'd get back that ID, and then you'd have to wait and check to see if it's done responding or poll. And then eventually you can do a GET request and fetch the messages from the LLM. So there's a lot going on there, but Pinecone makes it really simple. There's a single API. So the same process is happening, but it's on the Pinecone server. And so on the left side of the app that I showed there earlier, where it's doing the vector retrieval, we're sending a post request, and it immediately returns the response. Maybe not quite instantly, but it's the direct return is the prompt response that you've been waiting on. You don't have to get back an ID or do the vector retrieval first. So everything is happening automatically on Pinecone server, and you don't have to mess with that polling and waiting for it to complete. So that's how our RAG pipeline is working right now. It's similar to that first slide, but all of it is happening and being orchestrated for us automatically by Pinecone. Now, Jason, on your side, you've got a similar setup. Do you want to tell us what's going on here?
Yep. So that top path is basically the same as that vector retrieval path that you suggested, right? So
Mm.
what I built was just a simple function that made use of Neo4j's GraphRag Python package, which under the hood does basically that same pattern for retrieval augmented generation. So the only difference is the retriever, instead of calling a vector database, is calling a graph database. So what it's doing is it's taking the query and looking at the schema of the graph database, generating a cipher query, and then running it against the database. And when it gets an appropriate answer, feeds that to another LLM that then gives the final answer. So that's the top path. And that's all wrapped in a Google Cloud Run instance that I got spun up. So yeah, probably it's not performant because it's been put together by myself instead of like the full engineering team.
Yeah.
So that's the top path, which is very similar. The bottom path, so over the weekend, I provided a second API route that Joseph could make use of. And this uses basically a fast API server that uses Crew AI as an agentic orchestration system and is connected to Neo4j's Cipher MCP server. So what that does is it gives those agents the ability to query the database however it wants and basically noodle out the answer from whatever type of query you've got. So this bottom process, a lot more calls, but it is capable of handling more complex questions than the GraphRag by itself.
Right. Yeah. And I think that's going to have a lot more of an effect with more complex questions that if you're doing your retrieval with a single request and you've got multiple pieces like the multi-hop, you got a question that involves products and customers and orders and whatever, right? If it's just a single API request, your ranking, like your top results or whatever, is going to start to affect that because chances are you're not going to get the piece that you need from the product and from the customer part and whatever, and have all of them be in the top 5 or 10 or however many chunks you're getting. But with your approach and the MCP that is running there, it's more autonomous. It can do multiple retrievals. So it might do a separate one for the product. Okay, I've got that piece of the data. And then it'll do a separate request for the orders and whatnot, compile all of that data, and then give a much more comprehensive answer. So yeah, yours is a little bit slower, but it's definitely way more powerful. So just as we're testing it out and seeing the vector one responding first, and I think yours has a lot more capability, and it's going to be able to answer those complex questions a lot better. But a little slower. Just wanted to call out why, because I think it's pretty awesome what you put together.
Thank you. Yes. Yeah, and that Crew AI approach is also more extensible, right? So just by adding in more MCP servers or more tools to the crews, you can start to ask way more interesting, more powerful questions, right? When you start tying in other data sources, your other services. Yeah. So anyways, but yeah, that's a good call out.
All right. Well, let's try one or two more questions, and then we will get into the back end and show how this works.
Okay.
All right. Let's do a question where vector is definitely going to be better, because there's a few times where, vector is able to use similarity search and answer things that the GraphRag is not able to do. So right here, we've got a bio for one of the staff, and it says that they were a product manager and have 10 years of experience with launching smartphones in a global market. So I want to ask a question of which staff member, would be good at something like this, but in a way that the vector is going to be better and that the graph database might not be able to answer it. So we can ask which staff member would be best to help with a mobile device launch in China. All right. So instead of smartphone, we're not using the exact words, and China instead of global, just to see if it's able to connect that. Well, that was quick. So it did find Dennis. The vector side had no problem with that question. And I suspect this is one that the GraphRag won't be able to come up with because there's no records or nodes or relationships based on those keywords there.
Right. Yeah. Since we're not doing a keyword search on the graph side, and the data doesn't contain like an ontology of like people's skills and whatnot to search. So I would presume the agent has no schema data to work with to get that info.
Hey, it actually got it.
But it did.
Interesting. Okay. So it took a little longer. I think it probably had to do multiple queries and dig a little deeper. It's pretty impressive, actually. I'm surprised that the graph
Actually,
got
yes.
that.
The agent would be able to figure that out because once it looks at the schema and goes like, oh, I've got bios for characters. What it probably did was it probably read through each of their bios and was like, oh.
That's cheating. If it reads
But
all of them and then the LLM decides, that's a little different. But
yeah, but I
pretty
mean
cool. It still got it.
that's the power of agents, right? Is that it will figure it out with the limited information that it has.
Yeah.
Right. And I mean that's exactly how a human would do it with without that graph schema already built in. It's like, okay, I've got these properties. This is how I would pull that data. I would do a keyword search, right?
Right. Awesome. Okay. I'm pretty surprised I got that one. Well, let's take a look at the app under the hood. And I just want to show how the APIs are connected here. This is really simple because of the way that everything is abstracted away in the slides we showed a little bit ago. On the vector side, Pinecone's taking care of everything. And it's just a single API call. Get this out of the way. So the body is just query and then taking the text from that input. And sorry, this is the Neo4j one. But they're both pretty much the same. So we've got an endpoint, we're posting a query to it, and it returns the final response. So we don't have to mess with doing the retrieval, combining that with the prompt, and then sending it to the LLM. All that's happening on the back end. And same with Pinecone. So this one has a little bit more. You can specify the model. I'm adding this include highlights, which tells Pinecone to return the vector chunks that were used to answer the question. So you could just get back the answer, but I like to see those citations and what was used there. And then stream false, you can turn this on if you want to see the data coming in like it's typing. And then that's about it. The role user, because it's a messages array and you got to say who was speaking there. But really the only thing that I'm changing from one query to the next is that input. So pretty much the same setup. We're sending one dynamic piece of data and it responds directly. And so both of those are tied together on the UI. When you send a prompt here, I click this button, that is calling this JS object function. And so this is the only code I have in the app. There's two APIs and this one simple JS function so that it will await both of these queries. And you could just use async and then await each one, but I'm wrapping it in this array with a promise.all so that they run concurrently instead of it waiting for the first one to finish and then starting the second one. But really, that's it. That's the only code involved in this app. And everything else is on the back end. Pinecone's abstracted that away. And then Jason, everything you've built actually was a lot more work, I think, on your end. But it gives you that same simplicity on the front end of being able to just send a prompt and get back to response. So now, if we wanted to combine these, I could just merge the response from yours with the response from mine and send that to an LLM, but it wouldn't know how those things are connected. So do you want to talk a little bit about that? Like, how would you build a hybrid RAG pipeline with both?
Right. So there are two approaches for that one. The simpler one is probably just to, again, do an agentic workflow where you just have an agent with the two tools to access the two different databases and have it figure out how to connect the two, right? That's going to involve a lot more calls and whatnot. The other approach is to use something like our GraphRag Python package, which has a built-in option to use other vector database stores. And what it does is it kind of simplifies the process of taking the ID it's within, say, Pinecone or another vector database and linking that to nodes in a graph database so that there is a connection between key data points. And then when you run like a GraphRag query, what it will do is it will do vector search on the target vector database, pull the matching nodes from the answers from the vector database, and then start searching around the graph to give additional context. So you're making use of both systems and they're tied together through basically an underlying ID that ties the two systems together.
Okay. So is it is there a standard? Is it like common to do the vector retrieval first and provide that as extra context to craft a better cipher query for the graph side? Or, you know, would it be more beneficial to get the graph results first and provide that to the vector so that it has, you know, it's like one side or the other seems like it's going to have an advantage because it was able to answer with extra context, right? So is there a convention there?
No, the package that we have will start with the vector and then do the graph retrieval afterwards. But you could imagine some scenarios where going through a graph first and then going to vector might make sense. So, I mean, I would invite, you know, folks to try both, or, you know, create a system that does both routes and then combine maybe those answers.
Yeah.
Or again, give an agent the ability to decide which route it wants to go through and then kind of choose which path it will go. That will probably be the most efficient way of doing it.
Okay. Yeah. And, you know, like you said, it's best to just test it. You know, there's theory and then there's practice, and pretty much everything with AI, whether it's chunk size and overlap, or, you know, how many properties or dimensions should you have in the vector store. There's so many variables that you can change, and there's some good guidelines or starting points. But every time I ask somebody that's like an expert in this stuff, they all say the same thing: is like, you've got to try it to see what works best for your domain, for your data. You know, it's not like it's one size fits all. It's going to always answer better this way, because the type of data that you're asking, the type of questions, you know, if you're looking for something really specific with vector, you might want smaller chunk size so that the chunk exactly answers it, you know. But if it's more of a general broad knowledge, or that ties lots of things together, it might be better to have larger chunks or overlap, because it's going to miss those connections if the data is split apart, you know. And imagine similar thing with graph databases. There's a lot of manual work and I don't know, like your own opinion or decisions that you're making when you decide how to relate the data and ingest it into the graph database. You know, you've got some flat CSV files, but you're trying to connect them into nodes and define those relationships. And like a lot of that's going to be just your own experience, or your just trial and error, right?
Yeah, exactly. And one thing I've noticed with graph rag systems is, especially with agents, or actually even retrievers, is what the LLM decides to use as the type of relationship, right? The name of the type.
Mm-hmm.
And so you're right, when you're importing data for, like, say, people working for other people, you know, I chose like, oh, this person works for so and so. But oftentimes, you know, in testing, the LLM wants to go the other way around and wants to go like, this person manages this person, or this person, you know, supervises. So it chose a different type for the relationship, but it is exactly the same type. But because it chose a different word,
Mm-hmm.
it may get, you know, it may not get any result until it finds the right where. And this is why giving it the schema is super helpful, because then the LLM can be like, oh, okay, these are my available relationship types. I should rephrase my question.
Yeah. Awesome, man. Well, this has been really cool to compare them side by side. I think we should maybe get together again and do this as a full hybrid platform, you know, that properly tie in everything with the relationships. Because like I said, I could link both of these responses together, and it's basically like naive rag, you know, just sending it, here's some data, and take your best chance at answering it. But ideally, you want those separate systems, the graph database and the vector database, to have a common key there that's related. So merging those, and by the time the LLM gets it, it's not guessing. It's like clearly relating records from both systems. I think that's the best approach. So
yeah, I would agree. Do we want to show off the data that we have in graph form? That
sure. Yeah. Do you want to screen share?
Yeah. Let me do that. Let me switch over to a database real quick, and then I'll screen share. Okay, screen share button is here, and I want to share my entire screen. Okay, are you able to see the Aura dashboard? Perfect. Okay, so this is a visualization of the graph data schema. If I zoom in, this might make it easier. So here we've got This is from all the different tables that I had set up, right? So for staff members, delivery services, vendors, products, and the big one, the order that kind of ties everything together. So I think all of this kind of makes sense in terms of like relationship, right? Like this staff member works for a company, this person works for that company. This one might seem a little strange, I think, for folks new to Graph is like, oh, you've got this relationship that goes back into itself. And this is for representing that you have basically a hierarchy of staff, right? So if we were to pull out a little here, and so if I just did a call looking at just the staff and who works for who, I would get data like this. And so here I can quickly see like, oh, Lana Patel is probably the leader, the CEO, right? Since everyone works for her to some degree.
Yeah.
So yeah, so this is one fun thing about graphs is you can quickly see like hierarchy trees like this in the data.
Right. So on that tree there, every node is a person and they're connected to different people. But that first one you showed, it was like a single node representing the entire set of people that was connected back to itself.
Yes. Yeah. So this schema represents all the data. So all these relationships shows that for every combined staff node, there's going to be at least one of them has like a works for relationship to a company or oversees a vendor. So these are all the possible data connections between the different label types and relationships inside the graph database. And for reference, here is what all the data we have, which isn't a very big data set, but you can, right, you can already see it. It's quite like visually complex to see like, wow, there's a lot of relationships between orders, vendors, and users. And you can imagine a much bigger data set being quite a challenge to noodle through.
Sure. It looks like a lot when you select everything like that, but it's really more useful when you start to drill down and you only want to look at certain staff members or products or whatever. So yeah, it looks like a crazy spider web right now, but if you drill down and try to answer a specific question and you get only the nodes that apply to that question, right? That's where it becomes really useful to just at a glance be able to see how all those things are connected. And it's only the things that are, pertaining to your question, basically.
Right, exactly. Another advantage about interfacing with the graph directly is when you ask some of those complex questions, right? Oftentimes, at least the graph retriever will present the Cypher query, and Cypher is the query language that Neo4j uses for querying graph data. You can actually take that query, or you can manually create a query, and you can run it to verify the answer that you got is actually true, right? Because with like a vector only approach that's going to do some sort of math calculations, and maybe even an agent that's doing this, verifying that it's giving you the correct answer is you want to be able to audit those types of questions, right? And you can do that with a graph database.
Really cool, man. I've only been learning about graph databases and Cypher queries for maybe 6 months now, but really interesting technology. I think it's at the beginning of a boom that it's going to go through in the same way that vector databases did, 3 or 4 years ago with the rise of LLMs. Like AI has been out for years, but it wasn't until, just recently, the last couple of years, that it's had a huge influence over vector databases. And I see the same thing about to happen with graph. It's got some really cool advantages and the types of questions it can answer that it just seems like it's going to be the next big growth phase, I think, for tech and AI.
Oh yeah. Yeah, I totally agree with that. And again, it's a technology that can stack on top of everything that people have already built, right? Like vector, again, is really good at certain stuff, and just, stack graph on top of that. And then now you've got a really powerful system.
Yeah. Yeah. Similar with Postgres, and it, added JSON storage, and then it becomes, a better competitor to like MongoDB instead of having 2 different databases, right? Like if you can get one that does everything. And it seems like Neo4j is kind of going that route too. You also have a way to store regular vectors, right? To where you do everything in one system.
Yeah. So nodes can store vector embedding. So you can have the whole shebang inside graph as well.
Awesome. Well, man, is there anything from your side that you want to, as we're wrapping up, any announcements for the Neo4j community or somebody new trying out graph databases?
Yes. So if you're new and want to learn more about graphs, or already a graph user and want to like dig even deeper and upskill, we have a free online certificate and learning course called Graph Academy. So you can actually, pick and choose specific courses if you want as well too. So this has everything from just Neo4j specific fundamentals to learning more about Cipher, and also AI section, right? So we have a Gen AI bit here, right here. So even if you just want to kind of know just the basics of Gen AI and vectors, and then build on top of that how to add graphs on top of that, we've got courses, and the team is always constantly putting out new content. So this would be my number one recommendation if you want to learn more, is to jump into Graph Academy.
Awesome. I've been seeing a lot of people on LinkedIn lately posting the certifications from that,
Oh,
and
yes. Yeah.
and it is on my to-do list. I'm messing around with Neo4j all the time. I've got a local instance set up, but I haven't just really sat down and started the course yet. I do plan on trying a few of them, which reminds me, we have a course series of courses actually coming up for Appsmith. So I believe that wraps up everything we wanted to go over today. So I'm going to hand it off to Kevin, and he can tell us a little bit more about the Appsmith courses coming up.
That was packed. That was a lot. Hey, thank you so much, Joseph and Jason, or like I like to call them, Double J. You have seen how combining the vector and the graph rack transform basic information retrieval into more intelligent relationship discovery. Now, before we sign things off, everything we talk about today is waiting for you. Check out the description or the chat messages for guides, and also definitely join to our community portal to create your free account and start learning about Appsmith and all the different rack content that we have over there. Then head out to the graphacademy.neo4j.com to master graph databases. And lastly, start building your own hybrid RAG agents with Appsmith. Go to appsmith.com/AI and you can literally connect more than 30 data sources for your RAG pipeline in seconds, along with function calling, without even writing a single line of code. Hey, do not forget to subscribe to both Appsmith and Neo4j channels, because when two platforms this powerful collaborate, you don't want to miss what happens next. So hey, make that happen. Once again, thank you so much for joining us today. See you on the next building session. Goodbye.